Alrighty. Let's start today with kind of just going over like what I have planned for the rest of the semester here. Whoops. I've already disconnected the thing. There we go. Today is going to be kind of like our last new material day. There's really not much left. We just are going to cover maybe one or two new things, and then we're done. We have all the information we need. So that's today, where we're going to cover the rest of that stuff. What I'm going to do for this class is I'm going to not give kind of required homework for this chapter. What I'm going to do is I'm going to post some problems, and then I'm going to post the key. So you're welcome to try them on your own and then check with the key just like normal, but I'm not going to collect it or grade it or anything. So that'll just be kind of what you guys want to do with that. So I'll post that on Canvas for you later, so you can practice your pH stuff and identifying acids and bases. Yeah, so that'll be that. So my suggestion is for you to spend, what day is it? Today's 23rd, so I would suggest that you spend tomorrow and the day after on your lab projects, just to kind of get them out of the way so that when the due date comes around, nobody's kind of scrambling at the last minute. And also given the fact that the week after is going to be kind of, when I can have time to look at your projects and give you feedback on them. So the more complete they are, the kind of better feedback I can give you next week, and then kind of the better grade you're going to end up with, right? Because the more that I can say, hey, you know what, tweak this, fix this, add another couple of sentences here or whatever, if you're 90% done with it, I can help you out with that 90%, and then the other 10%, you just finish up and submit it. So so I would suggest you do that tomorrow and Wednesday, since we won't really have any new material to go over. So with that, then the week after, so that would be 11:30, 12:1, and 12:2. So I sent out an email and posted on Discord yesterday that I have kind of put like some time slots up for project reviews. So I put the website in, because I can just show you now. Oh, how silly. There it is. Let's go ahead and see where that is. It's going to be here in, I'll just go that slowly. It's in the text channels, just for the general thing. There's one called Lab Project Review Signups. There's a website there that you can click, and it's going to give you some, like a spreadsheet kind of thing, and you can just click the time slot you want, and then you can kind of like book it, and then we'll meet up and we can I can have a look at it and give you guys some feedback. So yeah, so that's there. Totally optional. You do not have to do these project reviews, but it can't hurt you, right? So I would recommend that hopefully each group will be able to at least have one person meet with me to go over their project, so I can help you guys out. All right, what we're going to do on 12:3, we're going to have just kind of general Q&A. So if you want to go over, say, hey, can we do an empirical formula problem again? Or, hey, can we, I didn't quite get this idea of, I don't know, percent yield, whatever. We can do some stuff on that. All right, so then 12:6, that is when your projects are due. And so those will be submitted on Canvas. 12:7, we're going to do another Q&A, so kind of the last review period. And then after that, you will have your final exam. So it is going to be on the 8th and 9th. You can choose which, what you have 48 hours to take it basically. And it'll be, I think, 2.5 hours or so. I'll have to double check with Saracosa's guidelines. And it'll be 50 questions that kind of span the whole course. So yeah, that'll be kind of what's on that exam. So of course it is cumulative, but again, chemistry, most of the stuff has just been building on itself anyway. So like stuff that we've learned way back when, like molar mass or something, we've been using all the time. So nothing terribly new for most of this stuff. Some of the stuff like empirical formula, that's going to be, stuff that we've thrown away out of our minds. But other than that, we'll be okay. Cool. So any questions on kind of the schedule of what's happening? So just to make it a bit more clear, I will be streaming on these 2 days. So I guess you'll only have to see me 2 more times this whole semester. So it'll be kind of nice. So as always, of course, while I'm only streaming 2 more times for you guys, of course, as always, a lot of you have already been doing, but just send me questions on Discord, put them in our chat, we can go over things. It would be a good idea if you can kind of like come up with topics that are tough for you. Even if you can't make the Q&A things, just, I can put something out there just so that you can watch it later and be like, oh, that's right, that's how we did this percent yield thing. So, we can try and do it that way. So, with that, how exciting, we're almost done. So of course, we do have Thanksgiving this week as well. So I'm not saying you have to work on your projects and stuff, but it would be a good idea if you wanted to do that. So cool. All right, anything about the schedule here? Alrighty, so just, I guess, these would be the same times as normal for those Q&A things. All right, just so you know, if the 8th and 9th, since it is not our usual Monday for exams, since I wanted to give you kind of a break after your project, before your final, if the 8th and 9th, you've got work or something and you don't have 2.5 hours of time, let me know. We'll figure out what to do with that. But hopefully this should be enough of a period where you can kind of set aside 2.5 hours to do it. So it'll be just like our last exam, so it'll be on the same kind of proctorio thing. And you'll have your open notes, all that stuff, though it did seem a lot of you did realize that if you have a whole book of notes, it takes a very long time to kind of go through them. So you may want to be very like concise, like make it like a cheat sheet or two, trying to kind of condense it all down to as few pages as possible so it's easy to look stuff up. Alrighty, and with that, that's gonna be it for us. Then we're finally out of here, and we can go and enjoy the winter. So cool. Alrighty, well with that, let's go ahead and talk about our last couple of topics here. So, one that that you might be using for lab, I think at least one of your groups is using this technique, which is called titration. It's a way of, it's a kind of a lab method for determining the volume of a solution needed to react. So, we've kind of talked about, hey, if I have this many grams of whatever and I throw in this many mLs of whatever molar solution, blah, 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 what's the limiting reactant and all that sort of thing. this is a method that will allow you to kind of make that determination of how much stuff you'll need to add. This is typically done for acid base, but it can be done for certain redox reactions as well. And the reason it's mostly used for acid base is because we can use this property of pH to kind of let us know exactly when the reaction is done. So if you're doing like a precipitation reaction or something, it's kind of hard to say, did I add enough to react all of the, silver ions in my solution or something? It may be hard to tell. So you typically will put excess in. However, for acid base, these react almost, 100%. And for us, we have actually certain chemical compounds that we can put into these that will change color based on the pH of the solution. So there's kind of some interesting things that pH does in real life. I don't know if any of you grow hydrangeas. I don't know if that's something that can be grown in the desert, but they're kind of plants that you can change the color of the flowers based on the pH of the soil. So you can have pink flowers, blue flowers, or purple flowers, kind of depending if you add certain ingredients to your fertilizer or whatever, or to your soil, you can kind of adjust the pH and change the color of the flowers. And so we're going to see we have compounds like that called indicators. Except I can't spell, as always. These things will change color at certain pHs. And there's a whole bunch of indicators, and they all have their own kind of range at which they change color. But the most common one is called phenolphthalein. You do not need to know how to spell this. It's not going to be a spelling test over here. But this one is a very important one because it is clear to around to pH 8. After 8, it turns pink. And so, oh really? So in is that Missouri or no? That's Mississippi. Missouri's MO. MS is Mississippi, I guess maybe. Or is that MI? Oh dear, it is Mississippi. Okay, well yeah. That's a more hospitable environment for growing plants. So. Did you notice that with your flowers? Did you ever try to change their flower color? But well, just you can. So it's pretty cool. So phenolphthalein is a compound that is clear up to about pH 8. So in acidic solution, it's clear, and then it turns bright pink once you hit pH 8. Okay. Well, that's cool. With that in mind, this kind of allows us to see very clearly once we've neutralized a solution. So if we're doing an acid-base reaction, if we want to know, when we're done with the reaction, when we've added enough acid or enough base, it'll turn clear or it'll turn pink when we're done with it. So we kind of can use this as a way of noting kind of exactly how much of our reactant was needed to complete the reaction. So, for example, you might have a known you may have, some known moles of acid or base. It doesn't really matter, but typically it's acid that we don't know. Acid that we do know. But you'll see we can do kind of the reverse process if we don't know the base. If we know the base. Sorry, I keep mixing it up. And so we'll have some known moles of acid. So either that we got that from grams, say we dissolved some amount of acid in this water, or we had a concentration of acid that we already know. What we can do is, there's a piece of equipment called a Buret. And that is basically a long, thin tube that has graduations on it. And these graduations are to the, so where you should read to the 0.01 ml. So these are pretty specific instruments. You're going to get usually about 4 sig figs out of using these. So these are pretty useful things. And so you'll typically fill that, if we have a known known acid, we'll put the base in here. We'll put the base in that Buret. And this allows us, we can kind of open the valve to release the base. And so if we have our acid here, we would basically open this and we would be able to kind of control the amount of base that we're adding. If we also throw our indicator in here, we'll be able to see when we have run out of acid. And once we've run out of acid, then we know we've added the correct amount of base. And then once we know the volume of that base, we can figure out its molarity, right? Since we'll be able to use our stoichiometry skills to say, okay, if I had 0.5 moles of acid here, and I used however many mLs of base, we can use our stoichiometry to figure out the molarity of that base. And so this sort of idea of titration is just a kind of lab method of figuring out the volume of solution you would need to react with something. This is also how they used to do, if you were drunk driving, as all of you do, shame on you. If you were to get the blood test for measuring your ethanol in your blood, they would do it by titration. So they would use redox chemistry. They would use dichromates, I think, to determine when they would be able to see exactly how much ethanol you had in your blood that way. So it's pretty cool. So it's a very useful kind of analytical technique. Suffice it to say, we normally this is an experiment we do. Of course, we don't have experiments, though there are videos that you had watched about titrations. So point is, you keep adding base until it's slightly pink. And then that means your reaction is done. And then you would read your Buret to see how much volume you used of your solution. And you would use that in some sort of calculation for something. So that's all we need to know about titration. However, we could kind of see, let's do a practice problem. Let's say we had what's a good acid to use? Let's use acetic acid. We add 25.26 ml of base to this solution until the solution turns slightly pink, which is, by the way, called the end point. The point at which you finish your titration. Of course, we have this indicator. And the amount of indicator we use is very small. Like, these things are very obvious to us. As soon as it turns pink, it's very obvious. So we just need a drop or two, and that's all you need for these. And these are already a pretty dilute solution anyway. So yeah. Anyways, so this is telling us we have a gram of acetic acid. and we've used a certain amount of base to it. And so we're going to try and figure out what is the molarity of the base. Bases are often harder to know the exact concentration of, because carbon dioxide in the air will actually react with bases, and so over time, if you leave your container open, your base will react with the air, and it will slowly become less and less basic over time. So acids, though, on the other hand, don't typically they'll typically hold on their concentrations. So let's go ahead and let's say our base was NaOH. Should probably give it some sort of thing so we can see a chemical reaction. So acetic acid. Plus sodium hydroxide. Standard double displacement. All our acid-base ones are going to be double displacement. So we're going to get sodium acetate and water. Hooray, it's already balanced. Lucky us. So let's just kind of digest this problem. It looks like we have 1 gram of the acetic acid. We have a volume of base, and we're asked to find the molarity. So we don't really need the products at all. We're just looking at the reactants here. And so that's all the information we have from this question. So we saw that it's going to take 25.26 mLs to get us to the endpoint. So we're going to try and now figure out what the concentration of that base was. So as always, we'll probably want to do a plan here. So it looks like we have grams of acetic acid. We want, at the end of the day, molarity of NaOH. So the only thing we can do with grams is just turn it into moles, right? Once we have moles, we can use our stoichiometry, our reaction coefficients, to get to moles of NaOH. And then we use our molarity definition to kind of get that to work out. So for this one, we will need our molar mass and our reaction coefficients. Let me just do this one in green. Just I'll be consistent with what we're doing here. So let's see. Let me look up the molar mass of acetic acid because nobody wants to actually calculate it. It is 60.052. Okay. Oh, I guess I should put acetic acid. I'm just going to write acid for all of these because it's a long chemical formula. Our reaction coefficients are already 1. And so we can do this. So 1 divided by 60.052. Okay, and that's going to be 0.016652 moles of NaOH. As always, we should double check our units. We have grams of acid, those cancel. Moles of acid, those cancel. So we have moles of NaOH left. Since we are asked for molarity and we are given a volume, we can plug that in. And so we just have to kind of plug the stuff in here. Looks like we have 2 sig figs. What was it, 25, 26? We do this and let's see what the answer is going to be. That's sad that the acetic acid has ruined all the sig fig work we had done for this solution. And so doing this, it looks like I get 0.66 molar NaOH. Ta-da! And so that's kind of how you would do a titration. So if you were to, and then now that you've kind of figured out the concentration of this base, you could then use it to figure out, the, moles of an acid or something or whatever. If you want to find concentration of an acid solution, same idea. You could use this like kind of freshly standardized base. So once you have figured out its molarity, it'll be good for at least that day or so, and then you can use it to do other calculations. So useful technique, kind of our first little bit of analytical chemistry here. So there we have it. So you see here, it's nothing really new. It's just kind of introducing you to the instrument that you would use, or the piece of glassware you would use. So hooray, there we go. Any questions on that one? This is really chapter 10 stuff, but just throwing in the word Buret now, or titration, or endpoint. So nothing terribly new here. Oops. But there we go. Alrighty then, we're on to our very last topic, which is something very important called a buffer. So a buffer is a solution which resists pH change. I have a video to show you of this. We can have a look. Actually, let me go ahead and pull that up. And then I'll show it to you guys so we can see, and then we'll talk about what makes a buffer, and that's it. So we're going to see these solutions are very important for biology, because we're going to see that, well, not here, but if you end up taking a biochemistry course at some point, or biology course, you'll find that proteins are very sensitive to pH. And so here, let's go ahead and open the window here. Yes, exactly why you would buffer it. So you'll see that different things may react different ways if they are not buffered. So here we go. So this is an unbuffered solution here. We have 6 beakers of deionized water that contain a universal indicator. So these, I'll just shut this up for a second. These all have a what's called a universal indicator in it. It's a mixture of different indicators that will just kind of change different colors depending on the pH. And so these are all just deionized water with that indicator mixture in it. And we're going to add small amounts of acid or base to these eventually. Okay. Here we go. So we're going to see I've added a little bit of acid to that one. Just 1 drop. We're going to add 2 drops to that one. And then a cajillion drops to that one. And we can see, so you can see here the color changes are pretty apparent, right? And we're going to see that the red kind of end of the spectrum is very acidic. On the basic side, we can see we kind of have this bluish one, and then a whole conjunct of base in there. We'll turn it purple. And we're going to see that these kind of, look, we have a nice little rainbow. Okay, with those, you can kind of see some rough idea of the pHs that are present. So we have red, we have almost, pH 0, really these low stomach acid pH ranges. And as we go to the blue-purple side, we're getting into very high ones. And so kind of that greenish area is around neutral. So if we go ahead and put a buffer in this, we're going to do the same experiment, but now I've buffered these solutions. Blah, blah, blah. So here's our 1 drop of acid, 2 drops of acid, or I guess 3, and a kajillion drops of acid. Nothing changes. Miraculous. Let's try the base though, just to be double, just to make sure. So on the base on the other side, couple drops versus a lot of drops. Lo and behold, no change. So we're going to see that these buffers will stop pH changes from happening. And so, okay, let's go back to our regular screen here. Okay, I'm glad the videos are working. That makes things a lot nicer to be able to show you visually. So yeah, so these buffers are able to keep things within a very narrow pH range. Your blood is especially sensitive to pH change. Your blood is pH 7.4. And if you even go to 7.35 or 7.45, you start feeling really sick. But you can see just like 1 drop of acid solution was enough to really just completely throw the pH down the toilet. And so you're going to see that in the blood you have 3 different you have at least 3 buffer systems that are helping to keep your pH exactly within this range. And so we're going to see that these are going to be made of weak acids and their conjugate bases. So, for example, in your blood, you have, bicarbonate in there. And so sodium bicarbonate, sodium would be the counter ion here just to balance things out. But if you were to have a mixture of bicarbonate and carbonate, that would be a buffer system. And since we know, our cells are continuously producing CO2 as we, oxidize our glucose, we learned that CO2 can combine with water to make carbonic acid. This is from CO2. Both of these things, actually. We're going to see that CO2 that is produced by your cells, which is acidic, needs to be kind of taken out of your body. And how your body does this is it converts it to bicarbonate. And so most of the CO2 that you are carrying around in your blood is actually not in the form of CO2 gas. You're going to see that, it's a very small proportion that's actually dissolved CO2. Most of it is carried around as bicarbonate. Some of it you will have attached to your hemoglobin called carbaminohemoglobin. You'll learn about that in biochemistry as well. But the vast majority of it is carried out as bicarbonate. And that bicarbonate is there because we're going to see, guess what? It's actually a very special one. We have 2 things that we could do with bicarbonate. Actually, that's it. If we take a look at this, if we add a base to our solution that has bicarbonate in it, if we add a base to this, the bicarbonate can give away a proton, and thereby kind of neutralizing that base, and it will become the carbonate anion. If we add an acid to our solution of bicarbonate, it can take that H and become carbonic acid. And remember that weak acids, like carbonic acids, do not release their protons very easily. So this would be, H+ from a strong acid. So say, your stomach acid or something. As soon as your stomach acid goes into your intestine, it's no longer going to be acidic because shorten your gallbladder that comes in at the beginning of your intestine is a bicarbonate based solution, which will very quickly neutralize all of that extra acid that comes from your stomach. Since we know, your stomach is pH around 1 or so, but your intestines are, pH 7.4 again, or thereabouts. I don't remember the exact numbers. But the idea here is that we're throwing in something that can react with both acids and bases. And so, if you have another one, let's say we have a buffer made of acetic acid and acetate. This is a common one done in labs. You're going to see that if you have a mixture of these two, this one can react with base, and this one can react with acid. And by having those present there, when you add extra acid or base, you end up just kind of populating the other side. So if you were to throw in, so say if you have a solution of acetic acid and acetate, if you throw in some acid, all you will end up doing is converting that acetate into acetic acid. You're just giving it a proton. And we're going to see that, remember, acetic acid doesn't dissociate a lot. Remember, like 1% of it is actually acidic. So that's going to greatly kind of mitigate any changes you would have in terms of pH. Just because, a strong acid would be 100% dissociated, a weak acid is only 1% dissociated or less. And so that's kind of how we can minimize the effects of these strong acids or strong bases. So very useful things here. They're typically able to, so if this example is neutralizing it by 99%, that's a huge amount, right? We're getting rid of 99% of extra acid or base around. Eventually, though, if you keep adding acid or base, the buffer capacity is reached. So if you add enough acid to it, you'll kind of completely react all of your acetate or whatever. And at that point, then you'll start having drastic pH changes again. So the buffer capacity is kind of like the limit of how much acid or base a buffer can take before it becomes overwhelmed. And that is how much acid or base can be added before the pH changes drastically. So we saw in that first video, we put 1 drop of acid, we made it, pH 5 or whatever. 2 drops of acid, we made it pH 4 or whatever, and then a whole bunch of acid, we dropped it to pH 1 or so. And then going basic, we saw the same idea. However, we saw even with the, acid or the buffer system, we saw that even if we added a whole bunch of that acid or base, nothing changed. And so again, the idea here is that, these can absorb quite a bit of trauma, as it were. They're kind of there to kind of make sure things stay, neutral, and then eventually they will be overwhelmed. So if you just keep adding acid, yes, you'll get your pH to change. So, but typically that's a pretty big limit there. So that's it. So what you will want to know for buffers, you want to know kind of what they're made of. So that's always going to be an acid and its conjugate base, both of which being weak. So you can't say, HCl is your acid and Cl- is your base, not going to work because the Cl- can't really react as a base. So you have to deal with weak acids, weak bases only. And then just understand that they kind of minimize pH change by being able to react with either one. So, you also have phosphate in your blood and urine that help to control the pH there as well. Phosphate can hold, 3 different protons, so at different pH ranges, it's got different amounts of protons on it. So that's another important one. And then you have a whole bunch of proteins as well that will help to kind of work as buffers in your body. So, and then, yeah, as Brittany has said, yeah, you often will buffer drugs as well because if they're in acidic solution or basic solution, they may become more or less potent. So if you want them to act a certain way, like lidocaine, you would use for local anesthetic, right, or an analgesic. You would want it to be effective so that you can dose it properly. If you don't buffer it, you end up running the risk that it's either going to work too well or it's not going to work at all, and then what's the point? So yeah, bad things can happen if your acids or bases are not controlled. So yeah, you'll see a lot of drugs will say buffered, like you'll have buffered aspirin that you can buy as well for this reason, is because aspirin will break down in the presence of acids or bases. So cool. Well, we're done. We're done with chemistry. Hooray! So, how does it feel? So it's awesome, right? We finished ahead of schedule, which is pretty nice. So we'll have a lot of this time to work on our projects and then to ask questions. So yeah, do you guys have anything you'd like to do in the last 20 minutes here, or 18 or whatever minutes we have? Oh, well, for what it's worth, let's see if we can see these two right here. They're all squashed together, wearing their same little outfits. So that's cute. Momo has been taken to sticking around here. You still have 2 more chances to see them, by the way. But yeah, they're being very cute right now. In fact, I'm going to take a picture so I can have it later. But yeah, so it's been an exciting semester, hasn't it? And think with the horrible disease out of the way, hopefully soon. I think spring we're still going to be online, but just as the vaccines are rolled out and people are eventually taking them, and there are several courses of them, so you can't just take one and be done. You have to keep going. But hopefully, I think by fall we'll be back in the classroom. So if any of you are planning to take 111, that should be offered in the fall, and then hopefully we can actually be in person. We can do our labs normally and have fun that way. So, but yeah, we'll see. So congratulations, you have survived COVID intro chem. So hooray. Alrighty, well, if there are no questions, as always, if you have stuff, through next week or whatever, yeah, go ahead, send me messages or whatever you like. I hope your projects are coming along smoothly. If by now, you've not been able to contact your lab mates, what I can do is throw a 0 on their grade. Not a permanent 0, but just, they'll get the email saying they got 0 on the lab project and their grade will plummet. And that might spark them to start doing something. So if any of you have noticed that you don't have, if you're missing a lab partner, say 3 of your 4 people are doing stuff, but then the last one isn't, and you've tried to contact them and they're just not responding, let me know. We'll see what we can do there. Let's see. So just to be very clear, I guess, all of you in the lab group, all 4 of you or all 5 of you for certain groups, will be submitting the identical kind of experiment design on Canvas. So just so I have a submission from all of you. So it'll be easy for me to see to grade them that way. The one that you're going to do individually is just kind of an assessment of how your group worked. You know, I'll ask you, what did you contribute? You know, do you believe everybody contributed equally? Was there a person or two who, you know, barely did anything at all, or, you know, were very hard to reach, or, you know, would only say hi once a week and that was it? You know, that's where you would put that information. And so you're graded, remember, kind of two ways. So you'll have your lab design, which is based or graded on, you know, how good the science is everything thorough, is everything safe, you know, that sort of idea. And then you'll have your individual one where it's like, you know, if your three other lab members are saying, you know, hey, Brittany did absolutely nothing, you know, this whole time, you know, she was just the worst lab partner in the world, you know, that's going to have an effect on Brittany's grade. Of course, that's, you know, not the case, because I know your lab group has been working really well, and you've got some good ideas in there. So not just an example. So, but yeah. So with that, I guess that's it. So that individual one is going to be like a quiz that you'll take, and it'll just have the questions, you'll put in your answers, and that's it. But your group submission will all be the same document. So either a PDF or a Word. Actually, I think PDF would just be the best way to do it. But yeah. Okay, so last things here then. That website for scheduling is up, so go ahead and take a look. If you've been able to discuss with your lab group what time would work for you, or again, if only one person can make it, that's fine. And then please send me a copy the midnight before, just so I can look it over, so I can give you as much feedback as possible within the time window that we have. Alrighty, well, with that, I will, I guess, see you next week, next Thursday, for questions and answers. So kind of spend the week reviewing, doing your lab stuff, but also review your, you know, old exams and all that, and bring questions next week. So have a super happy Thanksgiving. Please be safe. You know, if you haven't seen Grandma in a long time, it may not be a good idea to risk it unless you've, you know, been quarantining and all that stuff. So just be smart. So hopefully there will be no problems. So yep, happy Thanksgiving. Eat lots of food. Have some nice wine, or Crown for Brittany. You know, whatever your poison is. So I'll have wine. Yeah, and then I'll grade all your stuff. And everyone will get A's. It'll be nice. So yeah. So with that, yeah, okay. Take care, everyone. Be very safe. Enjoy Black Friday. Don't spend all of your money. But treat yourself. It's been a tough semester. Alrighty. See you next week.